Hello, this presentation is going to be about flood control and dealing with flooding and what we as people can do to minimize the hazards and risks from flooding. So if we want to try and predict when flood is, how floods are going to affect us and when the next one is going to be, remember that there are two different ways to do this. We have the equation of the recurrence interval, n+1 over m, where n is the total number of years that you have in your data set. M is the rank, 1 being the largest flood in your data set, 2 being the second largest flood in your data set, and so on. And then T is the recurrence interval. You could also calculate that with the graphical method, where you have a couple of recurrence intervals that you're working with, and you take the data and you can then plot that data out and extend it as far as you want. So if you wanted to figure out this recurrence interval, you could use that with this graphical method of calculating recurrence intervals for flooding. So in this case, though, we have two different ways to do this. And for many purposes, it's the 100-year flood, which is equal to the 1% flow. That's the really important one for all kinds of reasons. If you live inside the 100-year flood on the 100-year floodplain, you're required to have flood insurance if you have a mortgage on your house. We've talked about how you can't build or fill in the 100-year floodplain because that has issues. And so you can think about how we're going to calculate this. If you use this method, think about how long of a data set you need to do this. Well, let's just say n is equal to 9. Let's say you have 9 years of data. Well, then the largest flood that you can calculate is 9 plus 1. It's the largest flood, so m gets equal to 1. And so that works out to 10. So the recurrence interval would be a 10-year recurrence interval for that example where you have 10 years of data. So it's always going to be one more. The recurrence interval is always going to be one more than you have years of data. So to calculate the 100-year flood for T, you're going to need 99 years of data. We don't have 99 years of data in most places. Some we do. There's some gauges from the United States Geological Survey on the Passaic River that has been collecting data for more than 100 years. It's about 120 years or so at this point. And so we could do it with that. We could do it with that graphical method we talked about. But there's various advantages of doing this. Let's think about the sort of advantages and disadvantages of having lots of data. So let's say we have 100 years of flooding data for the Passaic River. Well, that 100 years is going to let us calculate the long recurrence intervals, like the 100-year flood. And it's going to fill in all kinds of dots on that graphical method, so we don't have to extrapolate pretty far. But what are we assuming about those 100 years? What are our assumptions about changes or not over time? What's happened to the watershed of the Passaic River over those 100 years? Think about that. Well, what changes did you come up with? Well, some big ones are changes in land use. So in that time, there's been more urban areas. That's going to create more runoff. There's changes in climate, where we have more precipitation these days than we did 100 years ago. And so if you have a long set of data, there's some advantages to that because it allows you to do things like this graphical method up here, and you're putting in lots of data points. But you're making assumptions about keeping things like land use, climate change, the amount of ice maybe you have in the watershed, all sorts of variables. You're keeping them relatively constant. And so there's both good things and bad things to having lots of data. if we explore this idea of hazards and risk. You remember the hazard is the event itself. So this case, it's the flood. And then risks is a combination of two components. It's the impact times the chance. And remember that impact can be measured in different ways. It could be injuries, it could be deaths, it could be economic damage, it could be days lost of work, it could be days lost of school, it could be houses destroyed, it could be habitat destroyed if you're talking about other animals and other plants. The chance then is that annual percent chance. So that's a percentage. And typically the impact is measured in dollars, which is sometimes easy to do. You know, if it's houses destroyed, well, you can calculate the value of that house. If it's an injury or a life destroyed, that's a little bit harder to calculate. For the most part, we have way more control over risk in our life. However, flooding is one of those very few natural hazards that we actually can control. If you think about other natural hazards like hurricanes, volcanoes, earthquakes, tsunamis, things like that, those are going to happen regardless of what we do. We can't stop a hurricane from happening. We can't stop an earthquake from happening. We can, though, potentially change the flood hazard. So what could we do to actually change the flood hazard that we have? Well, one of those is build a dam, so that could hold the water back and release it more slowly over time. We could build a levee. We'll talk about those potentially. We could reduce runoff. That would decrease the flooding amount. So these factors reduce the actual amount of floodwaters that we have, the actual amount of flooding that we have. These kind of actions will reduce the amount of flooding we have. There are some other things, though, that we can take that will reduce just the risk from flooding. They do nothing to the amount of floodwaters that are there, but they reduce either the percentages or the damages. So this would be things like raising or elevating homes. So if you have a house that's in that floodplain, but you're going to build it up and you're going to put something on that first floor that we don't really care too much if it gets flooded, maybe just an empty garage or something, that would be better. You think about most of the kind of vital infrastructure that keeps a house operating, where the electricity is, where the plumbing is, where the heating is, that's typically in the basement. And what's the first thing to flood? It's the basement. So sometimes those things get moved up higher. You could remove homes through what's called a buyout. And what happens with a buyout, a race, is that typically it's the government, it's almost always the government, they will buy out homes from a neighborhood. And this can be effective in reducing the damages that way. Of course, if you do the flood hazard, if you reduce the amount of flooding that you have, you're obviously going to reduce the risk as well. So if you reduce the flood hazard, that influences the flood risk. But for these last couple of items, all they're doing is reducing their risk. They don't actually change the amount of flooding that have at all. So those are our flood hazards. Now, we're going to talk a little bit more about levees. And so a levee is a flood control device that is pretty popular. And a levee is built to contain water on one side. So it's a wall. So, you picture, you picture a river here. You might have a big wall that's built next to that river, and that river is the levee. This is a river right there. So levees can do this. They are pretty effective, but let's see what happens at the watershed scale for what happens when we construct a levee. So this sketch up here that shows that wall, that levee right next to a river, that's a cross section because you're looking crossways in it, right? And so you could build some houses over here behind that levee. Okay, now we're going to look down on the world as if we're looking on a map. So we're going to have some river networks here. We're going to have some watersheds. And so what's going to happen is, let's say there's some houses right here. There's a town. This is my little town of whatever. And they're getting flooded by these rivers. So, these little squiggly things are my rivers. And so, well, what they're going to do is they're going to build a levee right there. So that's a levee. So next time it floods, those homes are protected. But think about where those floodwaters are going to go. They're just going to go downstream. That's a problem. How can we solve that? Oh, I know. We could build more levees. So now we're going to protect that part of the river. That'll solve it, right? Oh, wait, that's just going to... Oh, that's okay. We're going to build more levees. And we can keep protecting things farther. And if there's another town down here that needs some levees, well, we're going to build some levees down here. So levees don't really solve flooding. They just kind of move the problem downstream. They take all that flood water and they push it downstream. Now, if there's something really important that needs to be protected, maybe it's a power plant, maybe it's a hospital, maybe it's an evacuation zone where people are going to go to during emergencies, then sure, a levee can make some sense. But in terms of a long-term solution for a big area, levees don't work all that well. Levees also have the problem, like other flood control structures, and this includes flood control dams potentially, is that they go through this cycle. So some flood control is built. It's a dam, it's a levee, which means people feel safer. They think, okay, well, I'm behind this big concrete wall, so it's all good. And so they'll start doing things like, I don't know, building houses and constructing businesses in downtown districts and stuff like that. But eventually, there's going to be a big enough flood that there's going to be a lot of flood damages. Eventually, that levee is not going to be able to withhold every single flood that happens. So what happens? Well, we just get this cycle going over again, where if there's flood damages, well, then there's going to be a call for flood control. If there's flood control, well, then people are going to feel safe. And if people are feeling safe, they're going to start building more stuff. And so you get these weird cycles built in that are part of these step-by-step, where you get flood controls that changes the way people think and act, which then creates more risk because there's more things that could be flooded, and then create more damages that way. Okay, so that is the basics of some flood control, how we can try and predict these things, what the important flow is, and how that translates to